Good morning, girls. Children, as you know that we have already completed exercise 7.1. This is the next topic, some properties of the triangle. Now, under this heading, we are going to study the two theorems, which I'm going to show you now. And then we are going to solve some examples and the exercise questions. Okay. Now, under triangles, we are going to study some properties of the triangles. And under that, we have one theorem. Angles opposite to equal sides of an isosceles triangle are equal. Okay, first we are going to see what is an isosceles triangle. You all know that an isosceles triangle is a triangle in which two sides are equal and two angles are equal. Okay, now we are going to read the theorem statement that angles opposite to equal sides of an isosceles triangle are equal. For this theorem, I have drawn a triangle ABC in which AB is equal to AC given. Okay, so I will write given triangle ABC in which AB is equal to AC. Right, now we are going to, I'll write here to prove. To prove angle B is equal to angle C. Now this is a given statement, triangle with two sides equal, and we have to prove that angle B is equal to angle C. To prove this, we are going to do one construction. So the construction will be, we will draw a bisector of angle A. We will draw the bisector of angle A and we name it as AD, and bisector means this angle is equal to this angle. Okay, now we will prove these two triangles to be congruent, and then after that we are going to write that angle B will be equal to angle C by CPCT. So construction is draw AD, that is bisector of angle A. Now under the proof we are going to write in triangle ADB and triangle ADC. We know that in this triangle and in this triangle we know that AB is equal to AC, which is given. Then to prove the congruence, children, we need three conditions. Number two, this angle, as I told you that AD is a bisector, so angle BAD will be equal to CAD. Angle BAD will be equal to angle CAD, and the reason will be by construction. The third point will be the side which is common. As you can see that AD is common for both the triangles, so we are going to write AD is equal to DA, the common side. When we see the three corresponding parts, equal parts, we see that side, angle, side. So therefore we can write triangle ABD, triangle ADB is congruent to triangle which one? ADC by SAS rule. Okay, and therefore then we can write therefore angle B is equal to angle C by CPCT. Okay, so is it clear to you that we draw a triangle, isosceles triangle with two sides equal, then we'll draw a bisector of angle A, that is AD, then we'll take these two triangles, prove them to be congruent by SAS rule, and then we write angle B is equal to angle C, and that is by CPCT. So this completes your proof for theorem angles opposite to equal sides of the isosceles triangle are always equal. Okay, now next, the sides opposite to equal angles in a triangle are equal. This is the converse, we can write converse of theorem 1. According to the book, this is 7.3, and the previous theorem was 7.2. Now, as you can see that the triangle is same, isosceles triangle. The sides opposite to equal angles in a triangle are equal. Now these angles are equal. Okay, so we will write given what? Triangle ABC in which angle B is equal to angle C. This is given. Okay, now we write to prove. We have to prove that AB is equal to AC. This we have to prove. Now I have already drawn a bisector of angle A. It is not given in the question. I mean, it is not given in the proof. This was by construction. By construction, we'll draw AD, which is a bisector of BIS, bisector of angle A. Therefore, we'll write what? This angle is equal to this angle. Now we will prove that the two triangles are congruent, and then we will write that AB is equal to AC by CPCT. So what we'll do, we'll write proof in triangle BAD and triangle CAD. In triangle BAD and CAD, we write the first point. Angle B, angle B is equal to angle C given. Angle BAD, okay, this one, BAD is equal to angle CAD. Check CAD. This is by construction. Okay, then which side is a common side? AD is equal to DA. This is a common side for both the triangles. So therefore, AD is equal to DA. We can write the common side. Hence, you can see that there are two angles and one side. Okay, now check these two angles and this side. So therefore we can say that the triangles are congruent by AAS rule because the side is not included between the two angles. Okay, so therefore we can write what? Triangle BAD is congruent to triangle CAD by AAS rule, and therefore we can write, after this we can write AB is equal to AC CPCT. This proves the theorem, right? So we can check once again, the sides opposite to equal angles in a triangle are equal. We draw a triangle. AD is a bisector of angle A, and therefore angle B is equal to angle C, which is already given. BAD will be equal to CAD. This is another angle, but between these two angles we have this side. We don't have the included side, we have another side. So we will use which congruence? AAS rule, and then write AB is equal to AC by CPCT. So this completes your proof, for which theorem the sides opposite to equal angles are always equal. Now we have examples. Let us check one example now. Example 4. In triangle ABC, this is a triangle ABC, the bisector which is AD of angle A is perpendicular to side BC. Show that AB is equal to AC and the triangle ABC is isosceles. Now to prove that the triangle is isosceles, we have to say that the two sides are equal, right? So what we'll do, we will, example 4. As you know that the triangle which is given, ADBC. Now we have 2 points given over here. Number one is This is a bisector, and this bisector is also a perpendicular on BC. Fine. Now what do we have to prove? Check the question again. We have to show that AB is equal to AC. Okay, now what is given? In the given statement, we are going to write triangle ABC in which AD bisects angle A, right? All these points I am writing. In triangle ABC, AD bisects angle A and AD is perpendicular to BC. These points we are going to write. In triangle ABC, AD bisects angle A and AD is perpendicular to what? BC. Now, this is to prove AB is equal to AC. Now we know that if we have to go with the proof, in triangle BAD and triangle CAD, BAD is equal to CAD. Therefore, angle BAD is equal to angle CAD. Okay, this is given. How it is given? That AD is a bisector. Okay, then next will be, you know that when you look at the triangle, you will say that AD is equal to AD is the common side. Then the third point will be what? Triangle. In the triangle, this BAD and CAD, these two angles are 90 degree. So we can write third point as angle ADB is equal to angle ADC 90 degree. Okay. Now you can see that we have written the three corresponding equal parts. Check once again. BAD is equal to CAD, which is given. BAD is equal to CAD, given. Then BDA, or we can say ADB is equal to ADC. ADB is equal to ADC, which is 90 degree, and AD is equal to DA or AD common side. So therefore we will write, therefore the triangles are congruent by which rule? ASA. How ASA? Let's check. Angle and the side is included, so it will be ASA. Okay, so therefore I will take here ASA rule, and in the end we can write thus AB is equal to AC, and the reason will be obvious, CPCT. We can also say that if AB is equal to AC, triangle ABC is an isosceles triangle. Okay, this completes your question number, example number 4. I hope it is clear to you that first we will draw the triangle. Whatever points which are given, we will write that. You know that AD is a perpendicular to BC and AD is also the bisector of angle A. Using this, we are going to prove the two triangles to be congruent. And sorry children, there is no current now, so I will stop the video.